Now, we will do some practice doing measurements in class, but in addition to just the measurements, you also need to understand significant figures. I keep saying that depending on the piece of equipment, there's a limitation to how precise the measurement can be. With our triple beam balance, we were able to get down to 30.3 grams. But with our electronic balance, we only got 31 grams. So realize that there is some discrepancy there. And the triple beam balance actually gives us a measure that is more precise. When you see a significant figure, when you see a value, you can determine the significant figures, or how many sig figs there are. In this value here, 12.5 milliliters, there are 3 significant figures. 1, 2, and 5 are all significant. However, with all significant figures, you should know that the final digit, the final value, is always an estimated value. So we know for a fact there were 12 milliliters, but that 0.5 could have been rounded. Okay, so that's true of every value. If I give you 3.4 grams, 3 is a certain value, and then 0.4 is an estimated value. Okay, that is true all the time. Now, when you're trying to determine how many sig figs a value has, there are several rules that you must follow. I know that's a lot of text, but bear with me. The first rule is this: all non-zero numbers are significant. So here you have 273 grams. Every digit there is significant, so this value has 3 sig figs. Here you have 2.5 milliliters. Every single one of those values is a non-zero, therefore each one is significant, and you have 2 sig figs in this value. Now remember, that 2 is a known value, but that 0.5 is estimated. Same for this one. 270 grams is known, but those final 3 grams, that is estimated. The second rule is all zeros between non-zero numbers are significant. So when you have 102 grams, that 0 is significant, so don't leave it out. This value has 3 sig figs. When you have 110.5 milliliters, all 4 of those digits are significant. That 0 is in between 2 non-zero numbers. Therefore, all of it is significant, and this value has 4 sig figs. Zeros are really where it gets a little complicated. Leading zeros, any zeros that are in front of non-zeros, are not significant. They are never significant. So here, where you have 0.032 grams, this value only has 2 sig figs, the 3 and the 2. That 0.0 is not significant. Same thing for here, 0.00304 milliliters. This is very precise. However, you only have 3 sig figs, 3, 0, and 4. Don't forget this 0, it is in between 2 non-zero numbers, so it is significant. But the 2 zeros in front are not. So this value only has 3 sig figs. Here's where it gets even more interesting. Trailing zeros are sometimes significant, only if they are after a decimal. So trailing zeros are those that come after a non-zero number. So here you have a 2. The 0 that comes after it is trailing. Since it is after the decimal, it is significant. So you have 2 sig figs in this value. In this one, you have 3 sig figs. 0.0740 has 3 sig figs. However, one of those zeros is not significant. The leading 0 is not significant. Even though it's after the decimal zeros have to be trailing to be significant. So this one is This one is not. 0.0100. This value has 2 significant zeros and 2 non-significant zeros. These 2 zeros here are leading zeros. They are not significant. So these 3 values, right, or these 3 numbers or digits, those are significant digits for this measurement. Now, I missed one. What if you have 230 grams? You have 2 sig figs. This zero, this trailing zero, is not significant because it does not come after a decimal. Okay. Now, if you had a value that was 230.0 grams, now you have 4 sig figs. The reason for this is now you have a trailing zero that is also after a decimal. So now this zero is significant, but then everything before it, up until that 2, is also significant. So here you have 4 sig figs. It's very important to know how precise your measurements are, particularly when you are doing calculations. So when you are doing calculations with different measurements, and one measurement is more precise than another, you have to have a final value that reflects the least precise measurement. So when you are adding or subtracting numbers, notice that here you have 372.5, and I don't have a unit here, but for now that's okay. And we are adding 12.25. Now, both of these have 4 significant figures. All 4 digits here are significant, and all 4 digits here are significant. But when we are adding or subtracting, the final answer must have the same number of decimal places as the initial value with the fewest decimal places. So here we have 1 decimal place, and here we have 2 decimal places. When you do the math, you get 384.75, but the value here has too many sig figs. We are assuming that we have a more precise measurement than we really do. Since here we only have 1 decimal, here we have 2, we have to go with this value here. We're going to have to round this final answer to have only 1 decimal place. So it would be 384.8. I rounded that 7 to an 8 because this is a 5. So if the number after the final number that you're rounding is 5 or greater, then you're going to round up. If it is 0 or less than 5, then you're going to round down. So this would just remain a 7. When you are multiplying or dividing, it's a slightly different rule. So the final answer has to have the same number of sig figs as the initial value with the fewest sig figs. So with this, we're not actually looking at the number of decimal places. We are just looking at the total number of sig figs. This value here, 23.123, has 5 sig figs. 1.34 has 3 sig figs. Now, when you put this into a calculator, you're going to get a very precise answer, 30.98482. However, we cannot assume that our value is this precise because here our least precise answer only has 3 sig figs. So what we would need to do is round this number to 3 sig figs. That would be here. This gets a little tricky because if you're going to round that 9 up to a 0, and this would be 31, I mean, really, that's the only way to do that because that's an 8. So you're going to round up. the final answer here would be 31.0. You can't forget that 0 because it is still part of the value. It is still significant. It's just rounded. Okay. We will do more practice with this in class. You'll need lots of practice, and you'll get the hang of it very, very quickly. In all of your calculations from this point forward, I will be looking for you to keep track of significant figures. That's all for now, and see you in class.